Yo, welcome to hell. It seems like you've chosen death over delayed suffering, as I feel like hell here. Okay, dude, let's explore this abyss and come back like a king. Let's go. Life. When you were coding React, you had components, states, hooks, and conditional rendering. But when you enter assembly, you only have the will of CPU and some electric shocks. Sounds funny? Learning assembly those days wasn't like sitting on a computer, coding all day. It was more like standing inside a factory while the machine was still being built. There were no frameworks. There was no React. There wasn't even JavaScript. Just memory, instructions, and enough determination to convince a rock filled with electricity to do math. As a React developer, you're used to thinking this as a player object. But when you go to assembly, it asks move, CMP, and JMP. And suddenly, your CPU doesn't care about your components anymore. Because it wants precise instructions, every single time. And we can achieve this by making a simple tic-tac-toe using the assembly language. Okay, let's get into the setup. You need three things: NASM, Net-Wide Assembler, its language support extension. You can find it on VS Code. And finally, the assembly support extension, which is also in the VS Code. Yeah, the numbers you see here are the ancient CPU family. Let's not go there, or you won't be able to come back. And coming to this number, here X means any number. It can be even 1, 2, or even 3-digit number. And in the numbers, if only 86 is there, it is a 32-bit CPU. And if the number is attached to 64, then it means 64-bit CPU. Both of them meaning how many bits of data that the CPU can carry at a time. Want to know more on bits? Let's jump into the next curse. I'm not gonna lie. In React, state felt infinite. Need a value? I just need to add an useState hook with an array. Need 50 more values? I'll just add 50 more hook and I feel unstoppable. But when I switched to assembly, it said to take some random 4 guys with me for doing the same job. I don't know why. And when I showed them my hook, they looked at me with such disappointment and started walking with some data instead. It was really hard to understand these guys. And when I asked for their names, they called themselves as registers. Okay, here's what I learned to work with these guys. First, I had to create a file called main.asm in an empty folder and write org100h. Naturally, my React brain had a question. What on earth is this thing? It turns out org means origin, and 100h means hexadecimal 100. Think of it like giving Google Maps the correct house address before inviting guests. Without it, the CPU may arrive at your neighbor's house and start breaking their furniture. And at this point, I still didn't know what I was doing. But these guys seemed pleased. So I continued. Then I met the first guy. And it turns out that this guy was the main character. Nobody explained to me why. I mean, there were 4 of them, dude. But somehow AX kept showing up everywhere. Every tutorial, every code sample, every problem. It felt like that one employee who somehow attends every meeting in the company becomes the company's favorite. And with curiosity, I asked the assembly what the other guys do. I wasn't satisfied with the answers. Suddenly, it felt less like programming and more like assembling a dysfunctional superhero team. And the weirdest part? They are just tiny storage boxes living directly inside the CPU. Unlike React, they're absurdly fast. But then I discovered another problem. Apparently, these boxes aren't infinitely large. Which brings us back to bits. Remember when I mentioned 32-bit and 64-bit CPUs? A bit is the smallest thing a computer can understand, and it only knows 0 and 1. That's it. The entire internet, every React application, every game, every operating system, built from a terrifying amount of tiny zeros and ones. At this point, I was still confused. Then I saw my written code again, and my React brain immediately asked, what is MOV? What is 0003H? And why are we loading this poor AX guy with random numbers? It turns out that movie means move data. That's it. No magic, no framework, no dependency installation, just move data. Here, our code means take 0003H and place it inside AX. And then my React brain started asking, what was the weird number AX carrying? When searching, it turns out that it is a secret message for BIOS. So confusing, right? Likewise, while learning this language, when I removed one spider web, another web came out of nowhere, and I don't know why. I had to surf the internet to look out and learn every single concept. Unlike the magicians in the 1980s. And I was thinking, it's time to add the title to start seeing text on screen. Then, all of a sudden, I got a warning from CPU. The CPU looked at me and said, okay, you gave AX a secret message. Now what? I was confused. What do you mean, now what? I already suffered enough, bro. And then I found in the tutorials, I just have to write this int before touching anything. After that, once again, assembly decided to ruin my day. Because the movie part doesn't automatically doing any work here. It's just a mere transportation. And the registers, they were just messengers. The truth is, int was the true summoner of CPU, and when CPU arrives, move and AX sends their query, and CPU be like, okay bro, let me handle it. Like what the hell, dude? Did I just write all that to send a message? First, I had to find AX. Then I had to load AX. Then I had to learn MOV. Then I had to discover BIOS. Then I had to summon interrupt. And only then would the screen actually clear. At this point, I realized that assembly isn't one language. It's 550 languages hiding inside a trench coat. Every instruction introduces another concept. Every concept introduces another mystery. Every mystery introduces another rabbit hole. And somehow, the people learning this in the 1980s didn't have Stack Overflow, but had 1,000 pages of documentation, which explains why assembly programmers always look like they've seen things they can't talk about. But before I could recover from interrupts, I discovered something even worse. At first, I thought our board looked innocent, nice, clean, friendly, React brain approved. Then assembly introduced me to this creature, and suddenly I had another question. What happened to arrays? Where are my brackets? Is the DB means database storing my board? It turns out DB means define bytes, which is assembly's way of saying reserve some memory and put these values there. Not those arrays or brackets. So why do we use them in the React? This question haunted me for a while. Then I discovered one of the biggest plot twists in programming. React didn't replace memory. JavaScript didn't replace memory. Arrays didn't replace memory. They simply put a friendly face on top of it. When we write this, our React brain sees array, but the computer sees memory, memory, memory. One tiny box after another. And I realized the brackets were never the real thing. They were merely disguises. And unfortunately, assembly was just getting started. Because after creating the board, I wanted to draw it on the screen. And assembly looked at my component and said, We don't do that here. And instead, it introduced me to another curse. At first, I thought functions would be my safe place. Finally, something familiar, something I know. After all, React is basically functions wearing fancy clothes. Then I found this, and my React brain immediately translated it into this. But assembly laughed again. What an irritating bastard, and said call wasn't creating or rendering a component. It was literally telling the CPU, stop what you're doing. Go over there, do some work. Try not to die. Come back. And somehow that was considered a function. What? Okay. And then, I discovered something even strange. Every function needs an exit portal. Like for what, bro? Are you traveling between dimensions? And then I found that it was like a compass for CPU. Imagine entering a cave, exploring for 3 hours, finding treasure, and then discovering you forgot where the entrance was. That's basically what happens when a function forgets ret. The CPU gets lost. And unlike React, there isn't a giant red error screen telling you what happened. So, computer simply starts making life decisions without you. And that brings us to... At this point, I had survived the worst. I had memory. I had functions. I had a working tic-tac-toe board. Life was finally becoming peaceful. But assembly looked at me and said, "Not yet, bro." Everything started when I wanted to place an X on the board. My React brain immediately suggested simple, clean, civilized. Apparently, I wasn't allowed to touch the board directly because there is a new concept called pointers. And when I asked what it is, it said it's an address. Like what address, bro? House? Office? And I realized assembly doesn't care about your board. It cares about where your board lives. This line, here Leah means load effective address. Okay, at first I thought, nice. We finally found a place for board. And bro, it seems that the board was still somewhere else. We just have its address only. Like what? But before finding the truth, assembly got even stranger. It happened when I got the bracket error. I felt happy. It seems that the brackets were arrays all along. To confirm that, I asked the tutorials, and it explained me that those brackets are not arrays yet. I felt betrayed. And it continued. They mean, go to the address inside SI and bring me whatever lives there. Like what, bro? Are they some police officers? And at this point, I was convinced the bracket industry was a scam. Then came the final attack. This doesn't move memory. This doesn't move an array. But this literally walks to some location in memory and writes a value there, which means this innocent-looking line was secretly doing player positioning all along. And that's when I realized the terrible truth. Pointers are like having GPS coordinate of where I am, but not my house. They aren't evil. They are just being honest. It shakes your hand and tells you where the memory lives. Only JavaScript hides address from you. All right. We have our final tic-tac-toe code to execute. Finally, I had survived the worst. Oops. I just realized when you try to run it, it will show you, this app can't run on your PC. I know you have a question in the mind, but it's not JavaScript, dude. To run on browsers, you need an external environment known as DOSBox X. And when I searched on web on how to run our code, it says that you have to mount your folders first. So, when I did, DOSBox asked me, "Where is your project?" I gave it the path. It rejected. I gave it another path. It rejected that one too. What, bro? Very wrong, bro. And, I finally remembered. I forgot the quote. Now it worked. Apparently, the spaces in my folder names were the final boss all along. Victory. Or so I thought. Because when I ran dir, my files were gone. Completely gone. No source code. No executable. Nothing. For a brief moment, I genuinely believed I had deleted my project. Then I learned another lesson. DOSBox doesn't care about Windows drives. DOSBox has its own reality, its own universe. And you have to create a .com file to unlock that. Sounds like web, isn't it? In the terminal, where your main ASM file is located, type this command. You should see a new main.com file near your file. If not, solve the errors and retry. All right. After main.com is generated, once again, mount your project folder. And then check your project with dir command. If you can locate the .com file there, then you are ready to run main command. Run it. You should see the project running successfully. The intro appears, the board appears, and the keyboard input worked. And now, when you make some changes to the ASM file, you will not see the result. Why? Again, it isn't JavaScript, dude. You have to recompile it with your terminal, mount your project folder again, and then run main. Only then, your game will show the changes. Hits hard, right? It's because you aren't writing for browsers. You are writing for the machines. And you know what? Where there is will, there is way. And welcome back, King. Make sure to subscribe so we can go on more adventures together. See you then.